There is a planet in our solar system that humanity visited only once in 1986, and since then, never returned. Not because we didn't want to, but because what we found there was so strange, so impossible, that it shattered every law of physics we thought we understood. A planet that rolls like a bowling ball, with silent storms at negative 224 degrees Celsius, where diamonds rain through eternal darkness, and an ocean no one has ever seen is churning deep beneath ice and rock. This is not science fiction. This is Uranus, the forgotten planet. And its secrets are more terrifying than you imagine. January 24th, 1986. The Voyager 2 spacecraft had flown for 9.5 years through darkness to get here. 3 billion kilometers from Earth, so distant that sunlight was 400 times weaker. So cold, it reached minus 200 degrees Celsius. Signals took 2.5 hours to reach Earth. And as it screamed past Uranus at 50,000 kilometers per hour, it had just 6 hours. 6 hours to collect data, no second chances, no do-overs. And what it discovered left us with more questions than answers. The first images from Voyager? Disappointing. A pale blue-green sphere, almost featureless. No great red spot like Jupiter. No glorious rings like Saturn. Just emptiness. Scientists were let down. The media lost interest. The world turned away. But this visual serenity was a lie. Beneath the hydrocarbon haze hid the strangest environment in the solar system. A planet where the internal heat appears to have been switched off. Where seasons last 21 years. Where the magnetic field flips like a broken toy. And deep inside, an ocean no one expected is shaping everything. 40 years later, we still do not understand Uranus. And that is exactly why we must return. March 13th, 1781, Bath, England. A musician turned amateur astronomer named William Herschel was scanning the sky through his homemade telescope, and he saw something. Odd! Not a star. It moved. At first he thought it was a comet, but its orbit was too perfect, too circular, too calculated. This was not a comet. This was a planet. The first planet discovered since ancient times, doubling the known size of the solar system. A shock, a revolution. The universe had just become twice as large in a single night. But 200 years passed. Uranus remained a mystery, too distant, too faint, too small through telescopes. Even Hubble, the most powerful observatory in orbit, could only see a blurry blue smudge. No features, no answers. To truly see Uranus, we had to go there. And in 1977, NASA decided to do just that. Voyager 2 was launched. Destination: the outer planets. Mission: a journey of no return. Flight time to Uranus? 9.5 years. And for those entire 9.5 years, humanity waited, wondering what was waiting for us out there in the darkness. November 1985. Voyager 2 began its approach to Uranus. After 9.5 years in darkness, 9.5 years flying through emptiness, nothing to see but stars, no one to talk to, just silence. But now, the target was coming into view. Day by day, week by week, Uranus grew larger in the cameras, from a point of light to a fuzzy circle to a sphere with color, pale blue, almost featureless. Scientists at the Jet Propulsion Laboratory gathered around monitors. They had waited for this their entire careers. Some had worked on this mission for 10 years, and now there it was. Real. No longer a concept. No longer a dot in data. A world. January 24th, 1986. Closest approach day. Voyager 2 screamed past Uranus at a distance of 81,500 kilometers, 50 times faster than a bullet. No way to slow down. No way to turn back. 6 hours. That was all the time humanity had. 6 hours to take pictures, to measure, to discover. Every second mattered. Every measurement was priceless, because after these 6 hours, Voyager would vanish into darkness, headed for Neptune, headed for interstellar space, and Uranus would once again become a distant mystery. Cameras clicked, instruments recorded, data transmitted back to Earth at just 21 kilobits per second, 1,000 times slower than dial-up internet. Each line of each image took minutes to download, and as the first pictures appeared, the control room fell silent. What they saw? Not what they hoped for. A cyan sphere. Smooth. Nearly perfect. No storms like Jupiter. No exotic ice like Saturn. No swirling clouds like Neptune would have later. Just emptiness. One scientist whispered, "It looks like a billiard ball." The media had expected something spectacular. Something to write headlines about. Something for the front page. But Uranus gave them blandness. Interviews were cancelled. Stories dropped to back pages. The world quickly forgot about Uranus. Once again, the forgotten planet. But the scientists, they did not look away, because they knew something the public did not. What the cameras could see was only the surface, and the data was telling a completely different story. A story about something impossible, something wrong, something terrifying. While the world saw calm, Voyager's instruments measured chaos. Atmospheric temperature? Negative 224 degrees Celsius, the coldest in the solar system, colder than Neptune. Even though Uranus is 1.6 billion kilometers closer to the Sun. That made no sense. Physics did not allow that. But there it was. Magnetic field tilted 60 degrees from the rotation axis, as if someone had flipped a giant magnet upside down. No planet was like this. No theory could explain it. And beneath that serene haze, Voyager detected evidence of violence. Winds blowing at 900 kilometers per hour, faster than sound, stronger than any storm on Earth, but silent, invisible, hidden beneath the methane veil, and deeper still, in places no camera could see. The data hinted at something even stranger, an ocean, not water, but ammonia and salty water, supercritical, churning, conducting electricity, creating that insane magnetic field, and in the crushing pressure of the interior, carbon from methane was being crushed, compressed, crystallized into diamonds, diamond rain, falling toward a core no one would ever see. This was not a dead planet. This was a planet alive, breathing, hiding secrets that 40 years later, we are still trying to understand. Negative 224 degrees Celsius. That was the temperature Voyager measured at Uranus's tropopause. And that number broke every rule, because Uranus should not be that cold. Every other gas giant, Jupiter, Saturn, Neptune, radiates more heat than it receives from the Sun. Jupiter, 67% more. Saturn, 78% more. Neptune, 161% more. They are like giant furnaces, still hot from their formation. But Uranus? almost nothing. Heat out equals heat in, as if the internal heat switch had been turned off. Uranus is 14 times larger than Earth. It must have enormous primordial heat, but that heat is not escaping, trapped, or gone. Imagine this. Winter. You set your heater to 20 degrees Celsius, but the thermometer reads -10 degrees Celsius. Same as outside. Windows closed, doors sealed, heater working. But your house is freezing, 30 degrees colder than it should be. Something is actively cooling it. But what? That is Uranus. 30 degrees colder than physics predicts, radiating 2.8 terawatts of excess energy, equivalent to 2,800 power plants, vanishing into the void. Scientists check the obvious suspects. Nitrogen? 98% of the atmosphere. But nitrogen is terrible at radiating heat. Methane? Better. But not enough. Would need 100 times the current amount. The math did not work. Scientists worked like detectives. Suspect 1. Cold core. But no. Models show the core is still 5,000 to 6,000 degrees Celsius. Suspect 2. Thermal isolation? Possible. But why is Neptune not isolated? Suspect 3. Ancient impact blew away heat. Possible. But 4 billion years later, Uranus should have recovered. Suspect 4. Strange chemical composition. Maybe something in the atmosphere, acting like a giant refrigerator? And that is where the story gets interesting. There was a candidate. Something Voyager detected but could not fully measure. Something floating in the atmosphere, made of carbon. And to see it, we needed technology that 1986 did not have. The haze layers. That was the answer. Not gas, but particles. Tiny carbon particles floating in the atmosphere, created when methane is broken apart by sunlight. Tholins. Complex organic compounds. Reddish-brown. Sticky. And according to this new theory, they were working, absorbing sunlight, converting it to heat, and then radiating that heat back into space, like a giant heat sink, cooling the entire atmosphere by 30 degrees. But this was an extreme idea. In every planetary atmosphere, Earth, Mars, Jupiter, Titan, gases control energy. Particles are just background noise. But on Uranus, particles dominate. They are running the show. A completely new kind of climate. But no one could prove it. Voyager 2? It detected haze, photographed layers, but could not measure infrared radiation from particles, could not see them glowing. Hubble? Too weak. Signal too faint. Uranus too distant, too cold, too dark. To prove this theory, scientists needed to see the haze emitting heat in infrared, wavelengths the human eye cannot see, but telescopes can, if powerful enough, if sensitive enough, if designed right. In the early 2000s, such a telescope did not exist yet, but it was being built. The James Webb Space Telescope, expected launch 2021. Scientists would have to wait more than 15 years to know if they were right. December 25th, 2021. Christmas Day. James Webb launched. The most powerful space observatory ever built. A 6.5 meter mirror coated in gold. Designed to see infrared. To see heat. To see the invisible. Webb flew to L2, 1.5 million kilometers from Earth. No interference from Earth. No blinding from sunlight. Cold. Dark. Perfect. 6 months of deployment. Unfurling sunshield. Unfurling mirror. Calibrating. Testing. Summer 2022. Webb was ready. One of the first targets? Uranus. February 2023, Webb pointed at Uranus. Its golden mirror collected faint infrared light. Light no one had seen for 40 years. Scientists analyzed the spectrum, looking for one thing: excess infrared radiation. Clear evidence. And there, in the data, they found it. Emission at 7.7 micrometers, exactly where predicted. The haze particles were glowing, absorbing sunlight, emitting it as heat, pumping 2.8 terawatts into space. The crazy theory was right. This is a completely new kind of climate. For the first time, scientists found a world where solid particles, not gases, control climate. Uranus is a window into physics never seen. A natural experiment 3 billion kilometers away, 4 billion years running. Finally, we can see it. Webb continued observing, mapping temperature, tracking weather, studying rings, analyzing moons. Each observation, Uranus became less mysterious, less alien, but no less miraculous. Because now we understand. The heat switch was not turned off. Heat is still there, but the haze, those tiny particles, are preventing it from warming the atmosphere, radiating it away first. Uranus is not dead. It lives, breathes, just in a way no other world does. Uranus is not alone. It has 27 moons, 27 frozen worlds orbiting this tilted planet, and one moon tells the most horrifying story. Miranda, only 470 kilometers across. When Voyager 2 photographed it, scientists were stunned. The surface looked like Frankenstein, patched together, cliffs 10 kilometers high, 3 times the Grand Canyon, all terrain next to young, as if someone shattered Miranda, then reassembled the pieces. A moon that died and was reborn. What happened? A colossal impact. The same kind that tilted Uranus 4 billion years ago. An Earth-sized object slammed into Uranus. Catastrophic energy. Enough to flip a planet sideways. Shockwaves rippled through the entire system. Moons were crushed, melted, refrozen. Miranda was torn apart. Its interior exposed. Water, ice, rock, deep material, all mixed together. When it refroze, it froze wrong. Not in order, not in layers, like a jigsaw puzzle. That is why its surface looks this way. Why it appears dead and resurrected. Uranus and its moons are a time machine. Looking at them is looking back 4 billion years to the violent era of the solar system, when planets were forming, when impacts were routine, when worlds were shattered and remade. Uranus preserves the evidence. Its tilt, its shattered moons, its missing heat, all are fossil traces of an ancient event, an impact we will never witness, but we can read its signature. In every strange feature, every mystery, Uranus is not just a planet. It is a painting, drawn by gravity, by collision, by time. And we, finally, are learning to read it. Understanding Uranus is not just about Uranus. It is about thousands of worlds out there. The most common exoplanets? Not Earth-like, not Jupiter-like, but worlds between Earth and Neptune. Sub-Neptunes, ice giants. And we only have Uranus and Neptune to study. Uranus is the Rosetta Stone, the key to decoding those distant worlds. If we understand Uranus's atmosphere, its magnetic field, its interior structure, we can predict exoplanets. Are they habitable? Do they have protective magnetospheres? Do they have stable atmospheres? The answers lie in Uranus. 40 years since Voyager. 40 years of questions. And now, NASA has decided. Uranus orbiter and probe. Launch window 2031 to 32. Arrival 2044 to 46. This time, we will not just fly past. We will stay. Orbit for years. Drop a probe into the atmosphere. Listen to Uranus's heart. Map the hidden ocean. Finally, after nearly a century, we will understand. Uranus did not need to be a planet to be extraordinary.